Hello, Mr. Price, and this is the video on the Unit 13 on simultaneous equations for graphical methods. In this video we'll look at how to complete this homework properly, and there'll be some strong ties with the unit involving drawing linear graphs. Okay, so we have two equations here, y equals 3x minus 2.5 and y equals 2x plus 2, and I've been given this two tables to help me plot on this graph here. So I'm first going to substitute in negative 2 for my value of x. So 3 lots of negative 2 is negative 6, and then negative 6 take away 2.5 is negative 8.5. Okay, don't be tempted to go towards 0 there. If you've got a negative 6 and you go down by 2.5, you go down to negative 8.5. When x is 0, 3 lots of 0 is 0, take away 2.5 is negative 2.5, and then 3 lots of 2 is 6, take away 2.5 is 3.5. We'll do the same for my other table. So negative 2 lots of 2x is 4, and negative 2 times 2 is negative 4, plus 2 is negative 2. 0 lots of 2 is nothing, plus 2 is positive 2. And then 2 lots of 2 is 4, plus 2 is 6. We can now plot both of these on my graph. So, when x is negative 2, y is negative 8.5. Just need to move this over a little bit so you can see. So negative 2, 8.5 is here. 0, negative 2.5 is about, so that's 3, so 2.5 is about here. And then 2, 3.5, 2, 3.5 is about there. And let's join those up with a straight edge. I'm going to extend it a little bit further as well. Okay, so I extended it beyond my line here. Okay, now let's look at the other graph. So negative 2, negative 2. Here. 0, 2 is here. And then 2, 6 is here, and now I'm just going to extend my line. Okay, and extend my line a bit further here. Okay, and I'll see that they join up at this point here. Okay, so let's read across and down. So using my ruler, I'm going to read across from the point that they meet. And I'm also going to read down. Okay, and I noticed that actually my axis doesn't go that far. So just going to extend this line. Okay, so on my axis, every centimetre is a point. So this point here is 4. So my x value here looks like it's about 3.8, and my y value looks like it is 9. Okay. So now let's check my results by substituting back into my equations and see how close they are. So I've got y equals 3x minus 2.5. So let's substitute in my y value. 9 equals my x value, 3 lots of 3.8 minus 2.5. So 3 lots of 3.8 is 11.4. minus 2.5 is 9, and 11.4 take away 2.5 is 8.9. So 9 is approximately equal to 8.9. Turns out it was pretty accurate. We'll just double check it on the second equation as well. So y equals 2x plus 2. So 9 equals 2 lots of 3.8 plus 2. So 2 lots of 3.8 is 7.6 plus 2. And then 7.6 plus 2 is 9.6. So 9 is approximately equal to 9.6. This one's a little bit further away, so perhaps we might adjust our values a little bit. But this is a perfectly good estimate for this type of question. It will never give me an exact value unless I've got some nice equations with a really good graph that will help me see a little bit better. But that's a pretty good estimate. Perhaps you got a little bit more accurate than me when you did yours. Okay, now let's look at the second question. So here I'm being asked to plot two of these equations here on the graph below to work out their estimates for their solutions. Now here I'm going to do mine a slightly different way than using a table of results. I'm going to use my knowledge of y equals mx plus c. And I've got to remember that m is the gradient. That's how steep my line is. And c is where it crosses the y-axis. So I'm going to use that knowledge to help me plot my graph. Of course, there's no harm in doing the table of results as well, but this can be a bit quicker. So first, I'm going to put some values on my graph here. So 1, 2, 3, 4, 5, 6, -1. Okay, and now here I'm just going to go up in 2s for the moment. Okay, so let's look at my first equation. It's y equals 2x plus 3. So if I put y equals mx plus c above it, I can see it matches up nicely. Okay, so 2 is the gradient, and 3 is where it crosses the y-axis. So I know that it's going to cross my y-axis here. I've got my first point. Now I'm going to get another point which will be hopefully on my graph. I'm going to choose the value of 4. Okay, so just get one more value. So 4 lots of 2 is 8 plus 3 is 11. So at this point here, I want to plot my point here. And I can draw my straight line through it. Okay, and I'm going to label my graph. Y equals 2x plus 3. And on this graph, it's also nicely in the same format. Y equals mx plus c. So 4 is my gradient, and -3 is where it crosses my y-axis. So there's my first point. And I'm going to choose the value of 4 as well. Let's see if it's on the graph. So 4 lots of 4 is 16. Take away 3 is 13. So actually it is here. And I'll plot my two lines together. There we are, and here's my point of intersection. Let's read down and across. Okay, so my x value appears to be just shy of 3, so 2.9, and my y value is, let's see, so if that's about 9, so that's going to be just over halfway, maybe 8.8-ish. Again, your values may be slightly different, but around, as long as they're around that number, that's going to be pretty good. Let's check our accuracy. Let's see how accurate I was. So I have y equals 2x plus 3 and y equals 4x minus 3. So now let's check with substitution. So 8.8 equals 2 lots of 2.9 plus 3. So 2 lots of 2.9 is 5.8. So plus 3 is going to be 8.8. Oh, look at that, I'm spot on. So that is perfect. That one's spot on. Let's see how close the other value is. So y equals 4x minus 3. So 8.8 equals 4 lots of 2.9 minus 3. So 4 lots of 2.9 is 11.6. Okay, and then minus 3 is 8.6. There we are. So actually, this isn't the exact answer because I got a only a very slight estimate on this one. Sorry, I just realised I couldn't see any of that. So after substitution, I got one perfect answer and then one answer that was close. So this is not a perfect solution. So x is approximately equal to 2.9 and y is approximately equal to 8.8. It might vary slightly. Now possibly they could be whole numbers, so maybe 3 and 9 are the correct solutions. But this is close enough that it will do us for now. Okay, this is the unit on simultaneous equations graphical methods. And hopefully you found that useful, and do ask me questions in class if you need to. Thank you very much.